Hi, this is Project 23080. We were brought on by SunMed to make an automated PVC tube winding machine. We are Team Tube Winder. My name is Nick Williams. I am the team lead.
My name is Joseph Nimrod, and I'm the procurement lead.
I'm Miguel Quintero, an industrial engineer.
I'm Hector Castro and I'm an industrial engineer.
SunMed is a medical manufacturing company. There are facilities located in the US, Mexico, and China which distribute medical devices across the world. Currently, in SunMed factories, operators coil these medical tubes by hand, in which is a very tedious and time consuming process. Around 60 million tubes are coiled and distributed each year. This reduces efficiency throughout the process, and our main goal is to improve upon this by designing and manufacturing an automated PVC tube winding machine. By replacing this individual task of each operator, the efficiency of each warehouse will be greatly improved and the more medical products will be capable of being distributed across the world.
Our requirements for our automated PVC tube coiling machine are the following. It's coiling 7-foot long tubes in less than 6 seconds and having a cycle time of less than 7.5 seconds in a 4.5-inch inner diameter spool. It has to dispense the coiled PVC tubes to the operator in a neat and organized fashion without the use of adhesives or tapes. The whole machine should be able to perform safely, and we're going to be using an e-stop button to stop all operations and have lights and magnets to signify when doors are open. The machine should also be low cost and be able to fit on an operator's table.
Here is our automated PVC tube coiling machine in all of its glory. As you can see here, that's where you insert the tubes in our electrical box containing all of our wiring. Everything will be accessible through doors. And in the front, you can see our tube coiling system right here as it feeds in through a stainless steel tube. There's our tube slide, which we don't have quite installed yet. And voila. Here's our progression of designs throughout the entire year. We started off at the PDR with a hopper, to which there are multiple columns that you lay tubes through and feed through a single motor. This introduced many problems, to which we quickly evolved to our CDR design, which we had a multiple linear rail axis that the tubes laid over and fed into the system one by one through a PVC pipe. This evolved to our ISR design, which we utilized a stainless steel tube to feed them in, and we changed our tube slide, to which this led us to our final design, where we switched over to a hand feeder system, and the operator feeds a tube in, and it automatically recognizes that the tube is there and begins the tube coiling process. Here are all the SolidWorks views of our automated PVC tube winding machine. As you can see from the front view, there's our tube slide in the front. On the top view, you can see our two linear actuators and stepper motor connected to the tube coiler right there. From the right view, you can see our tube insert where the tube is inserted in to get fed into the system, as well as the electrical box on the bottom. From the left view, it's kind of just a different view of looking at the tube coiling system. And as you can see, all of this comes together to make our automatic tube coiling machine.
The stepper motors and linear actuators are controlled through drivers by the Arduino. We are also using a limit switch in the hand feeder to detect when a tube is there and begin the coiling operation. So there's really only two software states for our system. The first being when it's idle and waiting to detect a tube to begin the coiling operation, and the second state would be the coiling operation itself. The L298N is what controls both of our linear actuators, and the TB6600 is what controls both of the NEMA 23 stepper motors. We are also using a Hall effect sensor integrated with the Arduino that lets it know when each door is closed. So power comes into the system through a 24-volt barrel connector. From there, it goes directly to the emergency stop. After that, it powers the 24-volt stepper motors going into the transformer where 12-volt is outputted to the linear actuator controller. This is our wiring diagram for our system. Along the top, you can see the flow of power, and in the middle is our Arduino where it shows the pinouts to all of the different electrical components that we have. Here's a demonstration of our machine. The only thing missing is the tube slide that contains the tube to be dispensed to the operator. You can see as each of the doors are opened, it pauses all the moving parts in the system.
As you can see here, this is our verification table for our automated PVC tube coiling machine. To point out a few, our coil time and cycle time both pass, as we have hit 5.6 seconds for coil time and 6.88 seconds for cycle time. The only requirement that we have not passed for this machine yet is the orderliness of the coil as it's dispensed to the operator, which we will be testing and getting the results for before design day. This is a more in-depth look of our coil time results. As you can see on the right side in the table, we recorded the coil time, which we passed every trial that we had, as well as the clamp effectiveness, early uncoil, and the motor positioning of the tube coiling system, all of which passed throughout our trials. As for the cycle time test that we performed, you can see that one fail on there. This is where we realized that we can't use the same tube for all of our trials, as it gets deformed over time. So what we did is we changed up the tube being used every 3 to 5 trials, and we passed from there on out.
So moving on to our summary, the hand feeder system uses a limit switch that is triggered by a tube being inserted. And then after that, a drive wheel pushes the tube into the tube clamp, which is clamped by linear actuators. After that, a stepper motor begins to rotate coiling the tube. Once the tube is coiled, the linear actuators push off the tube, which insert the tube into the tube slide, ready for the operator to grab.
In conclusion, it is extremely difficult to control both ends of the tube, especially when dispensing the coil tube to the operator. Due to the tubes being pre-cut and non-rigid, it introduced a lot of randomness that we had to account for. Due to the length of the tube, having both stepper motors spin simultaneously at different speeds produced more of a challenge than we had initially expected. Some advice moving forward include using adhesive to contain coiled tubes to take away from variability, and to work with two closed loop drivers and two encoded stepper drivers.
Some problems that we encountered throughout the year was that we had to completely redesign our machine following PDR and ISR. One of the big changes was through ISR, we hopped over our hopper to our hand feeder design. For our T-slaw extrusions, we were unfamiliar with the machining we were doing, so there was very low tolerancing on that, so we just had to use the correct machines to tighten up the tolerances on that. One of the biggest problems we had to overcome was losing our electrical engineer 2 weeks before FAR, and also not having the machine for a total of 3 weeks during the second semester of Engineering 98.
The lessons learned throughout the year for our project include having better time management and better communication throughout the team, adapting to unexpected situations, searching for external feedback whenever needed, and the need to have consistent organization and a solid place to keep the equipment.
And we want to send a huge thank you out to SunMed, Rick Lopez, and Clint Poyle for giving us this incredible opportunity and supporting us throughout the year. We want to thank the engineering presentation panel for some incredible feedback and the influence that they gave us on our design throughout the year. And last but not least, we want to thank Steve Larimore for inspiring ideas in all of us and assisting us throughout the year through many concerns and problems that we had.